Welcome to the Deep Dive. Today, we're diving into something that, well, it touches everything from the hardest science to our own thoughts.
We're asking a pretty fundamental question. Why do our best ideas, our most powerful theories, always seem to fail in the end?
Right. And our mission today is to show you that these failures aren't really failures at all.
Exactly. They aren't bugs. They're features. They're reality, sort of peeling back a layer and showing us its actual structure.
Okay, so let's start with the classic example, the big one, physics.
Isaac Newton.
Isaac Newton. In 1687, he publishes his Principia and basically hands humanity the keys to the universe.
For 200 years, it was considered absolute truth. The universe was this perfect clockwork machine. You could predict everything.
It was the peak of certainty. But then, that certainty, it didn't last.
No, it shattered. And it shattered when Albert Einstein came along and showed that Newton's whole foundation was, well, it was incomplete.
And what I love about this story is how he did it. He didn't just tear Newton down.
No, not at all. He surrounded him.
He surrounded him. That's a great way to put it. He showed Newton's laws were just a special case, a regional map.
A perfect regional map.
Mm-hmm.
If you're in that region, low speeds, weak gravity, it works flawlessly.
So throwing a baseball.
Throwing a baseball, Newton is perfect. Yeah. But the moment you leave that territory...
Like launching a GPS satellite.
A GPS satellite is the perfect example. If you don't use Einstein's relativity for that, the entire system fails within minutes. The clocks drift. Navigation goes haywire.
So Newton wasn't wrong. His framework just had a boundary, a territory.
Precisely. And that's the core pattern we're tracing today. It's not about good theories replacing bad ones. It's about realizing every framework has a domain where it works brilliantly, and then it hits a wall.
And this happens with everything. Matter, economies.
Even our own minds. So to really see this pattern, we have to look at a couple of other major system failures.
Okay, let's pivot to economics. This is another area where we thought we had it all figured out.
Well, for a while, yeah. Just like Newton gave us mechanical certainty. After World War II, Keynesian economics gave us this feeling of control.
You could manage the whole economy like a machine. Pull some levers, push some buttons.
Right, and smooth out the business cycle. The whole thing was built on this really clean inverse relationship.
Unemployment goes down, inflation goes up. A simple trade-off.
A simple trade-off. And it gave governments this incredible confidence. They knew exactly what would happen when they intervened. Until they didn't. 1973, the oil crisis hits. And suddenly, the economy does something that the model said was just impossible.
It broke the rules.
It completely broke the rules.
Yeah.
The system produced stagflation.
So let's break that down. Stagnant growth.
Stagnant economic growth, yeah. But at the same time, you had soaring inflation.
Both at once, which the Keynesian world said could not happen.
Could not happen. The sources describe this as the economic equivalent of watching an apple fall up. It wasn't just a recession, it was a crisis of theory.
I find that amazing. You have this beautiful predictive model, and one shock from the outside world just shatters its core assumption.
And that sent everyone scrambling. It led to the rise of totally new models, like monetarism, trying to make sense of this new territory they'd stumbled into.
But that wasn't the last time the economic map failed, was it?
Oh, not even close. If 1973 was about a failure of assumptions around inflation, 2008 was a catastrophic failure of assumptions about stability.
Okay, tell us more about that. What was the assumption that broke in 2008?
Well, the risk models that, basically the entire global financial system was built on, they were based on a Gaussian distribution.
The bell curve.
The standard bell curve. And what that implies statistically is that extreme chaotic events, what some people call black swans, are so rare, they're basically impossible.
So they built the whole system on the idea that things would pretty much stay normal.
Exactly. And it worked in normal times. But when the system got really unstable, when you had panic and these crazy feedback loops,
all those impossible events started happening.
They didn't just start happening. They started to dominate reality.
Yeah.
The models weren't wrong about the quiet average day. They were just fatally wrong about the day the storm hit.
So again, a framework that was contextual, not universal.
It's the same pattern. The map only worked in calm weather.
Okay, this makes perfect sense. Let's make another, maybe even harder pivot to psychology, the science of us.
This is where it gets really personal. Because the boundaries here aren't in markets, they're inside our own heads.
For a huge chunk of the 20th century, one idea reigned supreme here, right?
Oh yeah, behaviorism. B.F. Skinner. The idea was incredibly elegant and radically simple.
Forget the mind, just treat it like a black box.
A black box. You don't need to look inside. All that matters is what you can measure. Stimulus, response, reinforcement.
And to be fair, it worked for a lot of things.
It worked beautifully. It could explain how we form habits, how to treat certain phobias. I mean, you can train animals to do unbelievable things with its principles.
So where did this super simple framework hit its boundary? What couldn't it explain?
Two huge things. The first was language.
Language.
Yeah, specifically how kids learn it. A 4-year-old can say sentences they have never, ever heard before. They can create novel ideas using grammatical rules they weren't explicitly taught.
So the black box wasn't just responding, it was generating.
It was a factory in there.
Yeah.
Something inside was creating structure, and behaviorism had no explanation for that.
Okay, so that's the first wall. What was the second one?
The second one is, I think, even more profound. It's consciousness itself.
The ghost in the machine.
The ghost in the machine. Behaviorism just dismissed our subjective felt experience, what philosophers call qualia.
Qualia. That's the actual feeling of seeing red, right? Or the specific taste of coffee.
Exactly. It's the experience itself. You can measure the brain waves and the neural activity associated with seeing red.
But you can't measure the feeling.
You cannot measure the feeling. And once psychology admitted that this boundary was real, the whole field it fractured.
So what did that look like?
Well, now you have all these different, equally necessary frameworks. You've got neuroscience looking at the brain scans, cognitive science looking at information processing, and phenomenology looking at subjective experience.
And the really wild thing is, the neuroscientist watching an fMRI and a therapist exploring your feelings, they're looking at the same person.
The exact same person. But they are describing two almost completely incompatible realities. They can't translate their findings into the other's language.
So this brings us all the way back to the meta principle you mentioned at the start. Physics, economics, psychology, the same story repeats.
Every single time, we build these incredible frameworks that seem universal, and then they fail at the boundaries. It's not a story about us getting closer to one final truth.
Which is counterintuitive. We're taught that science is all about unification, finding the one theory that explains everything.
Right, but what if the pattern is telling us that reality is fundamentally stratified, that it's layered, and each layer has its own rules?
Okay, so let's unpack that formula you mentioned earlier. The QF lambda, Q subsatec M day.
Right. It sounds complicated, but it's really just a map of what we've been talking about.
Let's do it conversationally. Start with F and lambda.
Okay. 5 laws is the framework or the field rule. Think of it as the set of laws: Newtonian gravity, Keynesian economics, behaviorism.
And lambda. Lambda is the scale.
It's the scale or the context. We use the Newtonian framework at a large scale, lambda, like a baseball, but we have to switch to the quantum framework for things at a tiny scale, lambda, like an electron.
So you switch your framework, your F, when the scale, the lambda, changes. But the real key, the part that defines the boundary, is the other half. The Q subsatec MDA.
That's the crucial part. Q is the prediction your framework makes. And knowledge is the measurable space.
The what?
The measurable space. It's what your tools can actually see and quantify. A framework breaks down when its prediction, Q, falls outside of what can be measured, dollars, in that field.
Let's use the consciousness example to make that concrete.
Perfect. So the field of neuroscience, its measurable space, its dollars, includes things like neural activity, blood flow, electrical impulses.
Okay.
So it can perfectly measure the brain activity related to you seeing the color red.
Yeah.
But the quality, the actual subjective feeling of redness,
that's not in its measurable space.
it's in a totally different measurable space.
Yeah.
The space of phenomenology, of subjective reporting. So neuroscience and phenomenology are just different. They overlap, they correlate, but you can't reduce one to the other.
Because you're measuring two different things, the thing and the experience of the thing. And this idea explains why the theory of everything in physics has been stuck for a century.
It really suggests that the whole quest might be misguided. We're looking for a single, simple ground floor of reality. But what if there is no ground floor?
Just more layers.
Stratification all the way down. Every time we peel back a layer and find something new like strings or particles, we just find new boundaries leading to an even deeper structure. Plurality might just be how reality is built.
That completely reframes the goal of science. It's not about finding the one final truth. It's about knowing which map to use for which territory.
And this applies directly to your life. To you, listening right now.
How so?
Think about your internal conflicts, the really common ones. Part of you wants to stay on the couch and eat comfort food.
And another part wants to go for a run, be healthy.
Exactly. And we usually experience that conflict as a personal failure, a lack of willpower.
But you're saying it's not a moral feeling, it's structural.
It's completely structural. You are operating under two different frameworks at the same time. There's a whole emotional framework, the emotional framework, which measures immediate comfort and satisfaction. That's its measurable space.
And then there's factional, right?
Right. And its measurable space is abstract long-term outcomes.
Hmm.
Both are giving you valid data within their own domains. The conflict you feel is literally the boundary between these two systems.
So wisdom isn't about one winning out over the other. It's not about crushing the emotional self.
No, it's about accepting that the boundaries are real. They aren't bugs to be fixed. True wisdom is knowing which framework to listen to in which context and how to navigate that space between them.
The conflict itself is information. It's telling you how you're built.
That's a perfect way to put it.
Wow. That's a powerful idea to end on. But let's close with one final thought.
If you look at the one thing we think is completely certain, mathematics, you find the exact same principle.
Even in math.
Even in math. For centuries, we thought Euclidean geometry was the only way to describe space. But then mathematicians discovered perfectly consistent non-Euclidean geometries. It turns out the rules of space itself are conditional.
And then there's Gödel.
And then there's Gödel's incompleteness theorems, which prove that any formal system, like arithmetic, will always contain true statements that it cannot prove from within its own rules.
So even math has boundaries it can't cross from the inside.
Exactly. So here's a final question for you. If mathematical truth, the very foundation of certainty, is conditional and has boundaries, what does that say about the limits of certainty in your own life? Perhaps the ultimate truth is that all truth is framework truth, and wisdom is just learning how to navigate the space between them.